we need to briefly talk about Wigglesworth, who was perhaps the founding father of a lot of the key insect hormones that you're familiar with. So he was the first to describe PTTH, right, which has that really long name, prothoracic tropical hormone, and also juvenile hormone. And a nice thing is this is work done in this bug over here, which is the kissing bug. I mean, it's interesting and a bit confronting in a way, because this was a guy who clearly, his brain was hardwired in maybe a slightly different way, but he basically decapitated insects, or he basically amputated insects, but then started to join them, right? So started to join them, and we refer to that technique as parabiosis. So these are two of these nymphs, right? So you can see there's no well-defined wing. These two nymphs here that are decapitated but then joined by with a little stent over here, where the head would have been, and conducted experiments where if in one insect you manipulated something, whether or not there is a measurable effect on the other. So this is parabiosis, where two insects could be joined and then shared a hemolymph. And you'll also see that there is another instance here where two different species, right? Well, they're both Lepidoptera, but two different species of moth and pupa were experimented on. But that's not the crux of the story. I think the important point is, what are the implications of experimental parabiosis? So I wanted to just do a couple scenarios with you here, and you can see the different colored roaches here, both decapitated and then head joined. I don't know, maybe some of you want to replicate these experiments, but in a nutshell, you can have a situation where if your experiment is applied to, say, the animal on the right, then you measure basically the response in the animal on the left. So you can, of course, increase specific hormones artificially via injection. And you could have instances where if I increase a hormone here, and if there's a subsequent increase in the other partner, without which has not been manipulated, then of course that tells you that this is a hormone that circulates in the hemolymph with a positive effect. You can of course have a situation where you increase the hormone in one and there is no effect in the other, and that might imply that that is a hormone that does not circulate in the hemolymph. Maybe it's a localized hormone. You can also have an effect where you increase the hormone in your test subject, and then the response measured is an antagonistic effect. And so that tells you that the hormone is again, a circulatory hormone in the hemolymph, which the two insects now share, but then has an antagonistic effect in terms of its function. So that's how you would interpret these parabiosis sort of experiments, where join them together, they are now stable, and then you manipulate one to measure the effect in the other.